Microservices. That was the most popular topic in last few years. In 2013, with Martin Fowler's book, after these several discussions about these microservices, people start to think some new architectural view for web applications. That's how microservices come into the picture. Now people are thinking whether we need to go for this or not. So as a software engineers, as architects, you have major role on this decision making process. To understand whether we should go or not, we should compare this with what we have right now and where we going to go. So this video is going to discuss about how you can migrate from web application into microservices world, whether or not, and disadvantages and advantages. So let's focus on video. What we have today we call as monolithic applications. Why it is as monolithic? Because it has single executable file for your entire application. This may be not executable, but you may say, okay, this is a WAR file or this is a ER file or some other archive. But the ground rule is your entire application is packed into one file. Just assume you have a rental car application, right? So you have a UI, you have a business layer, you have a car registration process, customer registration process, or renting process, and account or billing process. So all those processes are put together and ship as one file. So now just think you have to do small change, maybe UI, right? Maybe you are changing UI color, some simple thing, or maybe simple business logic. So you now need to ship entire file, right? So you change only simple thing, but you need to send entire file. So why this is matter? Because you need to test entire application, regression testing, right? So you need to performance test entire application. So you need to maybe you need to put down your entire application, send it to offline and to new version. So now this is little bit cumbersome work, right? So far we did this, but if we have a better approach for do this, why we don't do that? Okay, so that is one disadvantage of monolithic application. The second one, we are maintaining huge code base, right? Maybe sometime 50 engineers, 100 engineers, 150, 200 engineers are developing single application. So now we are maintaining huge code base. So when something comes up with production or maybe some issue, maybe some diagnostic thing, so now no one knows everything, right? So no one sees from one end to other end, right? So now you have to go through separate support process, right? Which may be huge to maintain, right? So if even though you want to debug, you have no idea where it come and where it go, right? So debug process is really hard. And deployment process. Deployment also hard because so you need to make sure everything is maybe your other side taking a traffic or maybe properly all the modules, all the applications, all the dependencies sent offline or rerouted traffic and so many things. And maybe if you have a deployment, if you have an installation, maybe entire team working overnight to make sure everything is smoothly transferred to new version or new build, right? Sometimes debugging and installation is nightmare with these monolithic application. Don't we have any advantage? Yes, you do have. The number one, it is easy to test because if you want to write an integration test, it's a single application, right? So you can write one test suite, you can test entire application because non-dependencies. You can access everything from your mock objects. And also, it is easy to monitor because it's a one application, you know exact path, right? So if you want to monitor this application, that is easy. So those type of advantages also are there. But now do we have any alternative to this problem? Before discuss about microservices, I must tell you this. Microservices is not something fallen from the sky which has a magical power, right? Therefore, don't get ready to throw out whatever in your hand and go to microservices. It is not something like that. Um, I'm not saying microservices isn't valuable. It is valuable, but as long as how you understand it. Um, some people says microservices is SOA 2.0, service oriented architecture, because whatever we understand as service oriented architecture is not successful as they expected. So if you don't know what is service oriented architecture, so I have other video on my channel, so you can go and watch that. Um, when it says microservices, so other paragraph of the other era of the service oriented architecture, it carrying some useful features what SOA had. Okay, so if you someone asks what is microservices, there is no exact definition for that, because it is something practice some architectural view, so there is no exact definition, right? If you say what is some Newton theory or something, you have a definition, but there is no definition for microservices. Martin Fowler tried to explain this in a way people can understand. I think now people take that as some baseline for microservices. So I'm not going to explain exact thing what Martin Fowler says, because you have Martin Fowler website and you have his book, you have enough documentation in the internet, so you can go and search those. He took some 9 points to explain if something is behave like this, we can call this as a microservices. But I'm not going to talk about that, because there is no way, no point of having other video to discuss exactly what someone said. Okay, let's try to understand microservices step by step. Microservices has dedicated purpose of living. In other words, it is domain driven development. It has to have a exact defined scope, right? So that is the one characteristic of microservices. Characteristic of microservices. It's hard to pronounce. And other than that, it should run its own process. It is running its own processes, right? It doesn't depend on someone else's. It can run all its own processes. Microservices can communicate some lightweight mechanism. Most of the time it is HTTP, but that is not limited to HTTP, right? So microservices usually communicated through its own lightweight mechanism. Microservices should be able to scale independently, right? Also, microservices should be able to deploy independently, and we should maintain decentralized control as much as possible, right? We should maintain decentralized control as much as possible. Uh, with considering all those facts, we usually say do one thing, do only one thing, don't try to do everything, but do it damn well. That is some baseline for microservices. If we recap again, what are the qualities of microservices? It should be able to independently scale, it should be able to independently deploy, and it should able to run on processors. It should have dedicated purpose of living, or otherwise exact scope of work. And in other way, it should be able to implement using different languages, different microservices. You should be able to implement different languages. And also maybe we should be able to develop this using small team, right? Smaller team, some people have a different definition for this small team. Usually some people says it should be two family size fed team, or some people says two large piece of fed team. Okay, so whatever it says, people head count should be 8 to 10, maybe 12, right? Because pizza example is not best thing because it's depend on how many pizza slices one person can eat, right? But usually, to understand this process, it says two family meal fed team. One of the key feature was we should be able to scale independently. I don't remember where I read this, but I read on one of the book. It says very beautiful way how the application scale should work. They took this is not my theory, or I can't remember the book. I'm sorry about it. There is a three axis: x, y, and z, right? So what it says, application should be able to scale out through x axis, right? So that mean if one instance is not enough, you should be able to spawn other instances and keep going, right? So we sometimes we say clustering, adding more data centers, whatever terms you can use, it should be able to scale out. And through z axis, it should be able to sharding, right? You know what database sharding and stuff. Maybe it should be able to geographically wise split out the traffic. For example, European customers is direct to European servers, and Asian customers direct to Asian servers, US customers different, like that. And through y axis, they says it should be able to functional decomposition, right? Functionally decomposition. So there our microservices come and fit functional decomposition. So if we take this functional decomposition, people says my system is very huge system, right? I can't think of microservices. Let's get our previous example, rent a car example. We have a single application to register customers, register vehicles, uh, rent vehicles, and billing, okay, and support 5. If we consider this as a large monolithic application, first phase would be, hey, take those 5 as a 5 different services, independent, right? 5 different independent services. Sometimes when people try to describe this, people says, okay, this one services validation should be one service, and data conversion should be one service, transformation should be other service. If there is a protocol conversion, that should be other service. No, that is wrong, right? If you are going with a too granular level, your microservices is fail. Why? Because microservices take some latency to talk to other service, right? It is not something like a single application or single service. It takes some time to communicate with other services. So you need to make sure make right balance, right? If you don't maintain the right balance, your microservices project is about to fail, is going to fail. So now when functional decomposition comes in the y-axis, right? If we talk about the previous example, we have 5 different services. Now we can split out these 5 different services. When you do this, you need to keep something in mind, right? Customer module has a customer, right? Plus support module has customer. This customer, when it comes to the support module, it is different perspective, right? It is different domain, it is different view. So that part you need to keep in mind. So that's why it says domain driven development, right? So when you implement a service, you should think and you should evaluate what is your domain, what is your objective, where you go with this customer, right? So now for example, in our given application, let's say we have 5 different services. Now let's say usually vehicle registration is not much heavy application, right? It doesn't take much heavy traffic because most of the time it is maintained by administration division. Let's say a search, let's say sixth one, search service, right? Search service may be the highest demanded service. So during holiday season, what we can do is we can spawn out new search service, right, to balance the load, right? We can spawn out 3, right? But we don't have to spawn out 3 different vehicle registration services, Why? Because that is not a much demanded service, right? So now you understand, right? So same application. Earlier, if you are doing the same thing, we should scale out. We should spawn out other instance from the entire application that contain UI, that contain search, that contain transaction, that contain vehicle registration, everything. But now here, what we do is we have 6 different services, but we creating other instances from search, right? Maybe renting on a holiday season. After holiday season is over, when it come to the normal traffic, we can push down, shut down all those other extra services, and we can maintain usual services. So that way it can save some cost, right? On demanding, elastic base, right? So elastic spawning, right? You can maintain that cost. So that's what we saying, functional decomposition plus that what says individually scalable, right? Individually scalable search service only we can scale. Let's focus how we can develop a microservice application. So actually this language what you're going to choose is, it's up to you, right? So that is a one feature of the microservices. Each services should be able to use different languages. However, usually people go with the Java, which is not must. You can use your own language. So if you go with Java, you should choose a good framework for you. Maybe you can use Spring Boot, maybe you can use Drop Wizard, maybe you can use WSO2 MS4J, microservices for Java, whatever the framework you are going to choose. When it comes to the design, it is very important you need to consider domain driven design, right. So you need to make sure your this service is not depending on other factors, right. So your service should be able to remove at any given time from the system and plug any given time from the system. That does not mean system should be able to run without your service, but what I am saying, your service, let us say in order to deploy your service, you should not be able to have a hard dependency to other service. If service A can deploy, if the service B deployed, you should not have that type of dependencies. And when you thinking particular, let us say customer, so you have to think customer domain or domain view from throughout your service. And most important part is service resilience and fault tolerance. It is not a feature, you must implement that. For example, let us say you have a service, you are going to invoke this service, you from your service you are going to invoke service B. So now service B is timeout, or service B is not working, or it is fail, right. So now you should be able to maintain this fault tolerance mechanism, you should be able to maintain this failure situation, right, that is called fault tolerance. So keep that in mind, right. There are multiple ways you can do this. You can have a failover mechanism, you can have a proxy, or you can have a circuit breaker pattern, right. So I will discuss those microservices pattern in different video, but now just think you must consider failover mechanism when you implementing microservices. The other point, don't try to reinvent the wheel, right. So what I am saying, there are various framework out there to support microservices development. So there are frameworks to deployment, right. For example, let us say you, if you hard coded other service name, next service name, if that service IP address or something is changed, then you have to deploy your service, right. So to avoid that, so there are API gateways or governance registry or that type of processes, and you should go with those processes, right. So don't try to invent everything. Certain companies I have seen, when I read through their papers, they have developed their own deployment mechanism. So that is fine as long as you can do and you can support it, right. Otherwise, you have a framework like Kubernetes and you have a various other framework, you can use those to deploy these microservices. So microservices, Dockers and containers, otherwise containers are always moving together, right. So in that case, to deploy your containers, you can use framework like Kubernetes. There are a lot of frameworks out there. I discussed in previous video as well. And when I'm discussing about microservice implementation, I'll try to talk few frameworks. And also you need to think restructure your team, because your team must have someone from the UI, someone from DB database, okay, someone from Java or whatever your service development, maybe QA, right? So you should have a full flex team which has everything, which know every areas, right? So we call this full stack team. So you need to think to build a full stack team, because implementing a microservices, one aspect is, one requirement is, they should have a visibility from consumer to backend, right? So they should have an analyst, they can have a QA engineer, they can have DB, UI, whatever, all the parties who involved for your service, you should have on board. So this restructuring team is little bit challenge if you used to have a separate database team and separate UI team like that. So finally, we call for microservices, you build it, you own it, right? So you build it, you own it. Why? So now the practice is, we build service, right, and we give this service to support team, right? So now we don't have any worry to get a midnight call or something. They have all worries. But microservices is not like that. You build it, you own it. So you need to make sure you build proper, strong, stable service. Otherwise, you will get a call from midnight from production support, right? So that is what called you build it, you own it. So actually, the one aspect of implementing a microservices and restructuring, so you distribute responsibilities throughout the team. Okay, there are enough advantages implementing this type of thing. Number one, especially if something production issue comes, right, team knows what happened, right? Team may composite with 10 to 12 members, right? We call team members. So those team members aware about entire service, right? So if production issue comes, it is very easy to understand or diagnose. Why? Because everyone knows inside. So number two, even though it will complex, right? So the service is isolated. Okay, so you don't have to read 1 million, 2 million code lines, right? It is just your service, right? So you know where what happened and where when it happened. um, Also, now your service can scalable. If we take our previous example, search service can spawn out to other containers and whenever required. uh, Also, if you feel like, okay, this whatever the implemented language is not doing well anymore, or your framework is outdated, it is very easy to migrate to different language or different framework, because your service don't have any dependency for other services. So I told you, microservice is not something fell from the sky and which has all the power. It has its own disadvantages. What? If you take the usual application, so dependency management or those type of thing, we have a centralized process. Now we distribute all these complexity, right? So we distribute all these complexity. Let's say our example, so we have 6 services. In our previous project, we had one dependency management system which take care of everything, but now we distributed all those complexity. Also, it would be really hard to monitor the application, because this is now not single application, multiple services, right? Also, it is not easy to test, because your service is isolated. If you want to run integration test, it would be a little hard to test because it depends on various other services. Versioning and deployment is you need to pay attention because if you change your version, the dependent services or other consumers who consume your service may be in a trouble, right? So, I'm creating a new other video saying mispractices of microservices. So, I'm going to talk this versioning thing uh, exactly here with the semantic version how we should follow. So, in a previous monolithic application, once application starts, everything is functioning, but when it comes to microservices applications, so you need to make sure all services are up and running in order to application to work. Okay, now conclusion. Uh, if you have a monolithic application, it is it's easy to monitor, it is to maintain, it is to monitor especially, and it would be hard to scale because it takes a lot of performance to scale. But when it comes to microservices, it is easy because various services are independent, isolated. What are the microservice application? Service should have a dedicated goal, service should be able to independently scale, service should be able to maintain by separate team, it should be able to implement any desired language. So, early application, maybe application is Java application, .NET application or something like that, but now it is not, right. The service, it can be a .NET, it can be a Java, it can be PHP, it can be anything. And what is the concept? You build it, you own it, right. So, team has a responsibility for your application. So, it is not isolated, communication is easy because each team can have a face to face communication, maybe across across the global different areas, but they should be able to communicate within the team because just 5-6 people or 10-12 people. So, maintain communication is really easy. So, team should be restructured, teams must have all the expertise, right, UI, database and everywhere. That is what about microservices, right. It is not a magic, it is a other way of service oriented architecture. So, now the problem is what are the good practices and what are the bad practices, right. So, I am going to do another video the common mispractices on microservices based on their understanding. Let us meet on that video.